Fortress Marine Anchors, stronger, faster, lighter, presents the 2014 Chesapeake Bay Anchor Holding Power Test. Here's marine expert and independent reviewer Chuck Hawley.
It's day 4 of the Fortress Mud Anchor Test near Solomons, Maryland. Today we're testing 8 of the anchors that we didn't test yesterday in our 5th location, which we call Echo. As with all of the testing, we start at a common point and then take different radial directions out from that central point so that we're pulling the anchors in undisturbed mud. Today we're using the preset method where we deploy each of the anchors at a 2.5 to 1 scope, and then we slowly winch them in for a time not to exceed 15 feet or 300 pounds of tension. The reason we do this is because this seems to be a good technique in soft mud, and it's recommended by Fortress for their anchors. The first test of the day was the Mantis. This has proved to be a pretty good anchor in the past, and today it had what I would say is sort of a picture-perfect pull. Doesn't mean that it pulled a lot of tension, but it started slowly, came to a peak, maintained high tension, roughly 550 pounds, and then slowly deteriorated at the end. We hypothesize that this reduced holding power at the end may be due to a reduction of scope as we pull the anchor closer and closer to the vessel. So this is the 5th pull with the CQR, again in our 5th location. I want to take a close look at this graph and tell you how confusing it can be to try to analyze simply the tension on the anchor line. I'll take you through this step by step. We have an initial slack line here shown by 60 pounds at 0 feet taken in. This is actually in seconds across the bottom axis. We have a quick pop up to 240 with about 10 feet pulled in. We have this, what we call kind of a bumping or a sinusoidal pattern, and then the anchor gets down to business here with about 360 to 400 pounds of tension. It slowly increases, and then rapidly declines down to essentially no engagement with the bottom. And then it rapidly comes back up here. This distance from this valley to this peak is only 16 seconds. 16 seconds corresponds to about 2.5 feet of anchor rode being pulled in. And yet the tension goes from roughly 90 pounds up to as much as 480 pounds. So, and then just to follow on, you can see we have some fairly consistent tension, a dip, consistent tension, a dip, consistent tension until the end of the test. Okay, so if you're buying an anchor or trying to select an anchor, what do you make of these tests? Well, the thing that we can't figure out is how an anchor could go from holding roughly 500 pounds of tension to almost 0 tension and back up to 500 pounds of tension in such a short distance. Because it's been our opinion along the way that anchors start on the surface, they're in soupy mud, they slowly engage, the mud gets firmer as they get down deeper, the holding power increases. So that all makes sense. But if you have an anchor that goes from high to low to high in as little as 40 seconds, which is 6 or 7 feet of distance, we really don't have an answer for that. We had the 5th test of the Fortress FX37 with the sand position 32 degrees. And boy, it was really a good test. Really similar in many ways to the Mantis, only with much higher holding power. We had some cyclical motion initially, went up to about 900 pounds, and stayed near 900 pounds with one spike over 1,000, and then slowly tapered off. But really towards the end, I think it was still above 800 pounds. We had a double of a time getting this anchor up, as is usually the case with the anchors that hold the most. And position the vessel over the top of it. We winch it up until we get to about 500 pounds, and we stop, and we wait. We winch it up a little bit more and wait, and finally we got it up. Anchor came up pretty clean, except with some compacted mud right in the crown area. So on the 5th pull of the Delta, we basically didn't see it engage the seabed. It may have touched 150 or 180 pounds on occasion, but it was a flat line all the way across the ground. So for the 5th and final test of the Rockna, we basically had a failure to set, very similar to the Delta that preceded it. Now this is in an area that's had quite a few good pulls with other kinds of anchors, so it's hard to attribute it to the bottom. We just don't know why these anchors have failed to set in this 5th test.
This protocol represents more likely how an anchor would be deployed off a boat in real conditions versus the other protocol, which would reflect more what would be experienced, say, in harsh weather when you got tidal storm surge and a depth of bury of the anchor to consider, where the scope may be shortening. I think what we're finding on the results is reflecting what can be experienced in real life conditions, both positive and negatively.
So our fifth and last test of the Manson Supreme had really good results, similar to some of the other anchors that we've tested in Location 5. Let's look at the graph. We have 2 minutes of cyclical motion ending right here at the 120-second mark. Then we have very consistent performance at about 500 pounds. Some of this is in the 460, 480. This is closer to 500. Then we get some interesting oscillations here. And as we said before, we actually can't imagine how an anchor could produce and not produce that much tension. So this is a little curious. But the anchor would appear to have broken out, but immediately reset and gone back to even higher levels. The remaining part of the anchor test is right around 700 pounds. From my memory, I think this is the best performance that the Manson Supreme has generated to date. The last test of the Spade was a little disappointing. We had an initial peak of around 300 pounds momentarily, and quite a bit of time spent at 240 pounds, and then it just slowly tapered off to basically dragging. The anchor came up clean, and we're not sure why it didn't set. During these tests, we've had a lot of comments when anchors have failed to set. We've asked ourselves, how much would simply the wire and the chain drag on the bottom? We don't really have a calibration for that. So we decided to test it. We paid out the same 20 feet of chain and 230 feet of cable and dragged it on the bottom for a full 10 minutes. It varied between about 20 pounds initially, all the way up to about 70 pounds, with the average being someplace around 55 or 60. Well, this is interesting because it sort of demonstrates that if an anchor doesn't pull more than that, or the difference between 55 and whatever the anchor's doing is just due to the anchor. Secondly, we found a approximately 45-pound piece of lead that's used to hold down scientific instrumentation. And it's not a very good anchor shape. It's not a ball shape, but it's kind of like a mushroom. So we threw that out on the end of the road, and at 5 minutes, we got a tension of about 136 pounds. So you can infer from this that if an anchor doesn't have more than about 135 pounds or so, that it's not actually, the shape of the anchor is not engaging the bottom at all. It's just the weight of the anchor dragging on the bottom. Throughout the week, there's been a lot of conjecture on how the little Fortress FX16 would perform in this muddy bottom. Now you may ask, if you're testing the larger anchor, the FX37, why would you care how an anchor that weighs about half as much would perform? Well, it's because in past tests, Fortress has seen some very, very good numbers out of this small anchor. And you would think that it would just be sort of proportionally less than the FX37. Well, boy, were we surprised. We deployed the FX16 at a 45-degree fluke angle, paid out the line as usual, and saw a steady increase up into the low 2,000-pound range. And again, this is on an anchor that weighs 10 pounds. We had a sudden release in pressure. This is one of these ones that is a little inexplicable because we actually believe that it had something to do with dynamic positioning and not the release of the anchor. Why do we think that? Well, we think that because as soon as we started putting tension on the anchor again, it went right up to 2,000 pounds again. And frankly, we got a little bit worried about our ability to retrieve the anchor. So after its second bump to 2,000 pounds, we stopped the test at about 7 minutes. In the process of trying to maneuver the boat to pick up the anchor, we came under tension one more time without having reeled in the anchor, and we had a spike to 4,000 pounds, and we had about a 15-minute process of struggling to get this anchor out of the bottom. When it came out, it had a completely different kind of mud on it. It was a very dry, crumbly mud, wouldn't stick together like that gelatinous material we'd had before, with a lot of sand and a lot of gravel and a lot of shells. We estimate that the anchor was at least 15 feet and perhaps as many as 20 feet down into the mud. We say this because when we got directly overhead and pulled up the cable and pulled up the chain, we still had about 20 feet of chain, or 20 feet of cable straight down. So this anchor was buried deeper than any anchor to date. Again, when we retrieved it, the anchor is in perfect condition, and we're going to give it another test. We did 2 more tests before wrapping up our Fortress mud anchor test in Solomons, Maryland. We did the FX16 again at a 45-degree fluke angle. Got about 1,000 pounds or so, maybe slightly more than that, whereupon it broke out, stayed broken out for a while, and then had one final peak. We also tried the FX16 at the 32-degree angle and got a little less tension, but it was surprising. In fact, the FX16 in that sand orientation would have outheld most of the other anchors in this test. Very impressive performance for a 10-pound anchor. So at the end of 4 days of testing off of Solomons, Maryland, we came away with a number of different impressions. One of the first things is that some of these anchors don't hold consistently, and so you may think you're anchored well, but a good anchor alarm and possibly setting a GPS proximity alarm is always a good idea. The second is that some of these anchors have consistently low performance, and you know, you could say, well, I'd rather have consistently high performance, but actually having an anchor you can depend on is a good thing. So you don't want an anchor that gives you a false sense of security. Some of the anchors failed to reset after they'd been set very, very firmly. We really can't explain that, but I think one issue may be the fact that this mud is so sticky and it clings to the anchor in various areas that it really affects the shape and the center of gravity of the anchor, so that once the anchor is firmly set and it's got mud on it, it may not be the same anchor the second time it tries to set. My overall impression from this is it's really rare that a company will spend this much money over a course of many days with many people to try to figure out what's really best. And this is how we learn generally in yachting and seamanship what works and what doesn't. So my hat's off to them for putting on a fair and very informative test. So I hope you've enjoyed watching our videos and reading the data. It's been a great experience for me. I want to advise you to be safe on the sea and make sure that anchor is set.